Hello and welcome. This is Nikhil Raj, Course Director for Tutomaash.com. In this video, we will give you an introduction to the basic terminologies in structures. Look at this picture. You might have seen like these buildings everywhere around you. Did you ever thought how these buildings get their strength from? Let's have a closer look. And then you can see the structural members like slab, beams, columns, footing, and shear walls. These are the elements that give strength to the building. Let's see how the loads are transferred in a building. All the loads in the building is carried by the slab, then it is transferred to the beam, and then to columns, footing, and at last it goes to the earth. These are the common load-bearing members in a structure. Apart from that, we have shear walls, which is used to take the lateral forces acting on the structure. To resist wind load and seismic load, we use shear walls in tall buildings. Staad.Pro is a structural analysis and design software. During structural analysis, program helps structural designer to understand the various forces acting and its effect on each element. Or program will tell you how the building responds to the given load. After analysis, Staad finds the reactions, shear force, bending moment, torsion, displacement, and stress. Once the structural analysis is done, you are ready to go for structural design. In our course, we explain the design of concrete and steel. From the structural analysis data, program will design each member to resist the acting load. After design, program tells you the reinforcement details, economical sections, volume of concrete required, weight of reinforcement, dia of steel, etc. Why reinforcement is provided to a beam? To understand this, I have come up with an example. When a load is subjected to this concrete beam, there are two forces which is generated. One is compression, another one is tension. Concrete is very good to take compression and it is very weak to take tension. It can even break in tension. So, in order to take tension due to the given load, we use steel. So, steel is used to take tension in the member. You might have heard about Fe415, Fe500 steel. This means Fe415 steel can take a tensile load of 415 Newton per mm square and Fe500 steel can take 500 Newton per mm square. And when it comes to concrete, concrete is used to take the compressive load. You might have heard about M25 concrete, M30 grade concrete. M25 grade concrete can take a compressive load of 25 Newton per mm square and M30 grade concrete can take a compressive load of 30 Newton per mm square. So I hope you understand why we provide reinforcement to the concrete beams. Let's see the reinforcement details. After the design, program tells you the reinforcement details, where we come to know how the steel should be placed inside the concrete. You might have noticed in buildings they use various sizes of columns and beams. So there is a question how to get reinforcement details such as dia of steel, center to center distance, shear lengths or stirrups data for various sizes of columns and beams. Answer for this question is, to get these data, we need shear force and bending moment values. What is shear force? To understand shear force, consider there is a beam of 6 meter length which is simply supported and it is carrying a load of 2 kN per meter. When 2 kN per meter load is acted upon the 6 meter beam, there is a reaction load which is induced in the support. Reaction in the support A is calculated using the equation WL by 2, where W is the load and L is the length, where you will get 6 kN of reaction load is acting in the supports. The same load is acting on the support B as well. Now let's see what happens to the beam when 2 kN per meter load is acted. You can see from the diagram there is a deformation in the edges. This deformation in the edges is occurred due to the shear force, and in this condition maximum shear force is occurring at the edges. Look at this figure. You can see there is a beam. This is a beam, and a force is acting downwards and a force is acting upwards. Due to these two forces, there can be beam shearing. It can cut off in this plane. This is what we call as beam shearing. So the force needed to shear the beam is what we call as shear force. And to calculate the shear force, you have to use this equation WL/2, where W is the given load and L is the length of the beam. So we got 6 kilonewton as the shear force which is applied to this beam. Next is bending moment. Consider the same 6 meter length beam which is simply supported and 2 kilonewton per meter load is applied, and this is the reaction 6 kilonewton. And let's see what happens to this beam once the load is given. You can see the maximum bending moment is occurring at the middle of this beam. So bending moment is the moment which trying to bend the member, and it is calculated using the equation WL²/8, where W is the load, L is the length, and you will get 9 kilonewton meter as the bending moment in this beam. And when you design this beam, you have to design in order to resist the bending moment and shear force. And this is the shear force and bending moment diagram which is done manually. And you can see when I done the same exercise in the Staad.Pro, Staad is also generating the same value. You can see the shear force as 6 and bending moment as 9. So we conclude by saying the calculation done manually and by program is generating the same values. So that's the end of the session, and we hope you understood well. Keep posting your queries and feedbacks, and for more videos please log into www.tutomaash.com. Thank you.